So the intermediate value theorem says let a and b be real numbers such that a is less than b. So one number is less than the other one. If f of x is a polynomial function such that f of a is not equal to f of b. So when I plug a into my function, I get a different value than if I were to plug b into the function. They're not equal. Then in the interval a, b, f of x takes on every value between f of a and f of b. And what does this all mean? It makes more sense if we draw a diagram. Let's draw an xy plane. And let's say a is here, and let's say b is here. And let's say when x is a, y, or f of a, is right here. Here's my point f of a, and let's say here's my point f of b. Okay, when x is b, y is up there. So all this theorem says is that if f of a is not the same as f of b, if there are two different y values, then f of x, my function, must take on every value between a and b. Because my polynomial is continuous, I have to connect from f of a to f of b somehow. So it could look like this, or it could look like this. But regardless, as I'm connecting, the difference, all of these y values between f of a and f of b will be covered by my graph, because I have to go from f of a up to f of b. So every point is going to be covered by my graph, f of x. And so if we have f of a as a negative number, and f of b happens to be a positive number, we can make a conclusion. We can say that there must be some number, c, that is between a and b, that has to be an x-intercept, such so that f of c has to equal 0. And thus we have the location of a root or 0. And again, that makes more sense if we draw a diagram. So let's draw an xy axis. And let's put a here, doesn't really matter, and let's put b here. Now we're saying that what if f of a happens to be a negative value? So here's f of a. And what if f of b is a positive value? So here's f of b. Now if that's true, if f of a is negative and f of b is positive, and my polynomial is continuous, I have to be able to connect from f of a to f of b somehow. And if I have to connect it, I have to go from a negative to a positive. Somewhere between a and b, I have to cross the x-axis. And here, this point c, this value c, is an x-intercept, because I must cross the x-axis. And the reason why we can make that conclusion is because polynomial functions are continuous. And so if I want to connect a point that has a negative y value to a point that has a positive y value, I have to somewhere cross the x-axis. And so again, my graph could look like this, and again, somewhere here I have to cross the x-axis, and that would be a 0. So if I know that f of a is negative and f of b is positive, then I know that there must be an x-intercept somewhere in between them.